this section, we're going to talk about veins, and we're going to start with the venules, which are the smallest of the veins and are going to carry blood away from the capillary bed. So here's the little capillary bed down here. The first venules and the smallest venules are called the postcapillary venules. The venules travel alongside and correspond to arterioles. So as the arterioles branch and get smaller, the venules fuse together and become larger correspondingly. The smallest drain the capillaries. They're going to have a wider lumen. The smallest ones still only have two tunics. They only have the tunica intima and the tunica media. And then as they fuse together and become larger, they're going to add the tunica externa, so the largest will have that tunica externa. Now the veins, you remember the lumen is wide, the tunica externa is the thickest part, the muscle layer is fairly narrow, and they have valves to prevent backflow. And that valve, remember, is just an extension of the tunica intima with elastic and collagen fibers to give it flexibility and strength. Now, as veins and venules fuse together, they become veins. As veins fuse together, they get bigger. And unlike the arteries, which you remember are elastic, muscular, and then arterioles, for the veins we just have small, medium, and large. The smallest are small veins, the mediums are medium, the large are large. The medium-sized tend to correspond with muscular arteries, the large correspond with elastic arteries. In many cases, we're going to have arteries and veins with the same name, carrying blood to and bringing blood from, say, an organ, but not always. So we'll go over some of those special cases. Now, because the blood traveling through the venous system is under very low pressure, we need another way to help move the blood through the veins. And the first thing we do is the skeletal muscle pump. As your muscles contract, they squeeze on the blood vessels that run through it. So as you're, for example, exercising, even just walking around, the muscles in your legs are contracting and then relaxing. And as they contract, they squeeze on the veins. As they squeeze on the veins, the blood gets pushed up and down. Well, it can't go down because of the valves, so it gets pushed up. And then as the muscle relaxes, stops squeezing the vein, then the blood flows back down, and as it does, it closes that valve. When a person is inactive, the blood tends to pool in the lower part of the body. So you do need to move around to keep your blood moving. And if you've ever had that feeling where you've been sitting, say you've been binge watching television and you just feel like, oh, I can't even think anymore. Part of that is just because your blood is literally moving more slowly through your body because your heart doesn't have to work as hard. And also a lot of your blood has pooled down in your legs and for your butt, for example, because the skeletal muscle pump hasn't been working to move that blood through your body. For those of you who are really fidgety when you sit, you're actually going to experience less of that feeling because even those little fidgets that you do help keep that skeletal muscle pump moving. Okay, so it's called the skeletal muscle pump because literally as your skeletal muscles move, they help to pump blood through the veins. Now we also have a respiratory pump. And again, this is the same kind of thing that's based on contraction and relaxation of muscles. This time, it's based primarily on the action of the diaphragm, although remember there are all those other muscles of respiration that help. The contraction of the diaphragm compresses the abdominal cavity, which raises the pressure in the abdominal cavity and raises the pressure on the blood vessels in the abdominal cavity. That's going to, again, help to push the blood up through the abdominal cavity into the thoracic cavity because, remember, the blood can't go backwards because of valves. As the diaphragm relaxes, It helps to, it's going to decrease the size, the volume of the thoracic cavity, increasing pressure on the veins in the thoracic cavity and helping to push blood to the heart. At the same time, the increase in size of the abdominal cavity is going to decrease pressure in the and decrease compression of the vein cavity, which is going to help pull blood from the lower body up into the abdominal cavity. So as you breathe, this respiratory pump is constantly working with compression and relaxation, pulling blood up into the abdominal cavity, pushing it up into the thoracic cavity, and then pushing it into the heart. And then once we're back to the heart, then the movement of the heart itself pushes the blood to get the circulation going again. So we have the skeletal muscle pump getting the blood back to the abdominal and thoracic cavities, and then the respiratory pump helping to move that blood through the abdominal and thoracic cavities and back into the heart. Okay, so that's the arteries, the capillaries, and the veins. One final thing for this section of lecture, let's talk about the changes in blood pressure. So I've been talking about this, the higher and lower blood pressure. This is a graph that shows the blood pressure at the aorta here, and then as it moves through the arteries, you can see it gradually decreases until it gets to the arterioles, and then there's very little pressure behind the blood as it moves through the capillaries, and then as it moves through the veins, there is less and less pressure behind it because this pressure from the heart has decreased and decreased. Once we get to the vena cava, there's almost no pressure behind the blood, but then the respiratory pump helps to pull the blood back to the heart. So the pulse is the blood that's being ejected from the left ventricle. So the pulse that you feel in your arm or in your neck is the blood, each pulse of blood being sent out of the left ventricle. The pressure is the force of that blood pushing on the walls of the blood vessel. So it's going to be highest in the aorta, lowest in the vena cava. Venae cavae is the plural of vena cava. If you want to measure your heart rate, put your index finger or your first two fingers, not your thumb, on the radial side of your wrist, just proximal to your carpal bones, where those little creases are on your wrist. And you'll feel that heartbeat right there. That radial artery is the easiest to feel. And then the other one that's easiest to feel is in your neck. If you feel your trachea, which is your windpipe, right on the front of your neck, on either side of it is where the carotid artery travels. And so if you feel right next to your trachea with your, again, index and middle finger, you will feel that, that pulse there. Okay, so you can feel how fast your heart is pumping. All right, so we're going to pause there, and I will come back with the next set. We're going to do a couple of lectures on the names of the various arteries in the different, or arteries and veins, excuse me, in the various parts of the body.